Yeah, in this video we'll be looking at implicit differentiation. Now, in implicit differentiation is a kind of differentiation where you have
X and Y are fully involved in such a way that you can't express Y in terms of X.
that kind of differentiation you know is an implicit implicit differentiation. For instance, if I have x squared y plus cos y equal 4. Now, if you look at this expression, I have x and y, fully involved. They are combined in such a way that I cannot separate x from y. So when you have a question in this form, you just know that you solve implicitly. It's unlike explicit differentiation. In explicit differentiation, y is expressed in terms of x, so therefore y is an explicit function of x. But in this case, it's a different case. So here, how do we solve this problem? Now, if you look at this, I have x squared y and then cos y equals 4. Now, this is a form of product. So I'm going to take this as u and I'll take this as v. If you remember from your product rule, to get the derivative, u dot the v dx plus v dot du dx. So I have two functions, x squared and y. Now, the v dx is the derivative of v, du dx is the derivative of u. In this function now, I'm going to use that. Now, we're going to differentiate with respect to x and with respect to y. Now, note this, each time you differentiate with respect to y, always multiply your derivative by dy dx. I'm going to say that again. Each time you differentiate with respect to y, always multiply your result, which is your derivative, by dy dx. Now, if you look at this, now u is x squared dot the v dx, it means the derivative of y. If I differentiate y, I'm going to get 1. Because I'm differentiating with respect to y, I'm going to multiply this by the y dx, plus then v is y dot. If I differentiate x squared, I'm going to have 2x. Now, I'm not going to multiply that by the y dx. Why? Because I'm differentiating with respect to x. So note that each time you differentiate with respect to y, multiply your result by the y dx. So I'm going to do this again. Now, the derivative of cos y will give me minus sine y. Look at your standard derivative. So for this, I'm going to get minus sine y. Because I'm differentiating with respect to y, I'm going to multiply my result by the y dx equal, the derivative of a constant is 0, so I'm going to write 0. Now I have this, I'm going to collect like terms. I'll express all the y dx will be on one side, this will go to the other side of the equation. So I have x squared the y dx minus sine y dot the y dx equal, if I take this to the other side, I'm going to get 2xy negative 2xy, because this is plus. Therefore, I'm going to factor out the y dx, which is my derivative. So the y dx will be x squared minus sine y equals minus 2xy. Then the next thing is to divide both sides by x squared minus sine y, x squared minus sine y. So I'll strike out this. So the y dx will give me minus 2x over x squared minus sine y. So this is very simple. So this is the derivative of this function using implicit differentiation. Thanks for watching my video. You can always subscribe on OG's Wealth of Math. Share the link. God bless you and bye.